Welcome. Today we'll be looking at two sections, and they're actually very similar to things we've already done. It's solving one-step equations, except this time it'll have decimals in it. And we'll be using the four basic operations again. In section 3.5, it covers adding and subtracting. In section 3.6, it covers multiplying and dividing. I have shortened it to just say solving one-step equations with decimals. You can find this on page, not 53, one can be found on 54, and the other can be found on page, if I remember correctly, it's page 150. So 3.5 can be found on 150, then one on 154. Okay, let's go ahead and get started because it's real easy. So we have decimals, we have this, we have an x, and we're told we need to solve. So the directions will say solve, and it's like, okay, what do? We got to get rid of whatever is with the x. And by with the x, I mean on the side of the equal sign with the x. If you want, you can always draw a line. Some students find this helpful. You can draw the whole line thing and say, where's the x? Over here. What's with it? That's with it. No, don't be silly. That is the 4.9. So we got to get rid of it. What do we do to get rid of it? We use inverse operation. Inverse kind of means you flip it around. You do the opposite. It says add, we say subtract. Because we're difficult like that. We just like, being difficult. So we subtract, and you're going to get x is equal to, what does x equal? Okay? That's the question. It might be helpful at this point, because it is a decimal, to come over here to the side and work it out. Let's remember the decimal rules. When adding or subtracting with decimals, the decimals must line up. If you need to, write that over to the side. It might be helpful for you. But decimals must line up when adding and subtracting, and we are subtracting. So I have 17.5 minus 4.9. So I go get 5 and I say minus 9. I can't do that. I'm going to have to borrow. Make sure you change the numbers. So I have 15 minus 9. I can do that. That equals 6. Okay, make sure the decimal ends up where it's supposed to be. Many people try to add the decimal at the end. They think, oh, I won't forget it. And they do, and they get the wrong answer. So keep up with the decimal, okay? Don't be silly. 4 minus the 6, 2. And when that 1 just comes on down, because you didn't borrow from it. So there you go. We end up with x is equal to 12.6. And the world rejoices. We got the right answer. Yay. Moving on. Here we have x minus 2.6 is equal to negative 20. Now we do have negative numbers here, so I would be wary about how this works. So I am going to have to add, because it says subtract. Remember, we just want to be difficult, so it says subtract. We say add, and we do it to both sides. Why to both sides? It's an equation. It's how it works, okay? Get over it. Okay, because it's decimals, we might want to come over to the side to do some scratch work because, hey, this could get confusing. Remember, adding and subtracting, decimals must line up. Negative 20 plus 6.2. People go, why did you put it there? I don't see a decimal up there. How do you line it up? What do you do? Well, a whole number has an understood decimal at the very end, right there, okay? Now, in order to add this or subtract this, we would have to put an extra 0 there. That's what you do. You fill the spaces in with zeros. Now, another reminder. Done with the decimal reminders, let's look at this. I have a negative plus a positive. How does that work? What actually happens when I add a positive and a negative together? If you remember, it works like subtraction, okay, when adding a positive and negative together. So I'm going to actually, I know it says add, but I'm actually going to subtract, okay? So I'd say 0 minus 6. I can't do that. I can't borrow from a 0, so I'm going to have to borrow from this guy. He becomes a 1. This becomes a 10. Then I can borrow from him. He becomes a 9. and this becomes a 10. Okay? So here we have 10 minus 6. I get 4. 9 minus 2. I get 7. Nothing's subtracting from the ones. The 1 just comes down. All right? Now look over here. Which number was bigger looking? Was 20 bigger looking or 2.6 bigger looking? The 20 was bigger looking. Was it positive or negative? It was negative. That means our answer is going to be negative. These are old rules, guys. If you're struggling with this stuff, you got to get a grip on it because we're not going to review over this stuff. It's old school. Okay, old school at this point. So x is equal to negative 17.4. I just want to point out that there's so many spots to go wrong here if you just weren't paying attention. Not lining the decimals up, forgetting that you have to add, forgetting that how negatives and positives work, their relationships with each other, forgetting dropping the negative sign, not putting the decimal in your answer. So many places to make a mistake. So you've got to be careful, okay? Let's move on to the next problems. Next problem, say we have 0.8 x is equal to negative 1.6. So what we're going to do here is we're going to have to divide in order to solve this, okay? So we're going to divide to solve this. We divide both sides by 0.8 because that is the number we wish to get rid of. All right. Now, some students may find it helpful to put 0.8 and put 0.16 under the hood to help us solve this. Now, reminder, when dividing decimals, here's a reminder, for dividing decimals, you cannot divide a decimal in decimals. You can divide it, you gotta get a whole number out here. So you scoot the decimal over 1, and if you move the decimal here 1, you must move it here 1. They must move the exact same direction and number of times, okay? 8 goes into 16. Well, that was pretty easy. 2 times. And if you multiply back, you know, you'll get 16. And hey, that worked out perfectly. We just have one small hinky-dinky little problem to keep up with. X is equal to 2. But remember, this was a negative divided by a positive. It means our answer is going to be negative. Always good to go back and look at stuff like that so you don't make sure you don't drop it off by accident, okay? Let's look at the next problem. Here we have, now look, I know all the ones we've been doing, we've been getting rid of the first number we see, but that's not what we've been doing really. We've been getting rid of the number by x. What number is by x? 2.3. All right, so that's what we need to get rid of. Don't worry about this guy. He's not in the way. This guy's in the way. We want x to be all alone. And this number's in the way. So we got to get rid of it. So we divide. And we got to divide this side because it's an equation. Okay? So we go ahead and put our little 2.3 going into 1.5 like so. Now, we end up moving the decimal over 1 time here and 1 time here. Some of you are like, wait, the decimal's still there. It's fine if the decimal's under the hood. It's the one outside that we're concerned about, okay? So put the decimal here, which means the decimal goes up here now too. See, decimal's here and here. So we'd say 23 into 11. That don't work. Well, what about 23 into 115? That does work, and it goes in there 5 times. If you multiply back, you get 115, 0. So our answer is 0.5. Okay? So x is equal to 0.5. Ooh, make sure you don't drop that decimal. It would be wrong if you did. Okay? That's it all worked out. You might need to make sure you have more room than I do. I'm going to put a line here, but y'all make sure you give yourself a little bit more room than I did. Don't want your notes looking all cramped like mine. Don't cramp your style. All right, next we have this, and how do we get rid of this? We have x divided by 2.5. If only I knew a way to get rid of division problems. Oh yeah, we can multiply. Multiply both sides by 2.5, okay? And you can write that over to the side. You can write it here by saying times 2.5 times 2.5. That cancels out, and you're left with just x is equal to, and now 7 times 2.5. Reminder about multiplication and division. Multiplication and division. What? Sorry, I'm going crazy. Multiplication and decimals. If you multiply decimals, you got to keep up with them, sonny. So here I have a 7 and 2.5. So I'm going to multiply here, okay? So I'm going to say 5 times the 7. 5 times 7 is, whoops, sorry about that, squeaky, squeaky, is 35. Now 2 times that. We got to put our 0 there, so 2 times the 7 is 14. We add this stuff together, we get 5, 7, 1. Good, 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 good. Very good. You then gotta put the decimal in the right spot. You got one number past the decimal there, you get one number past the decimal right there. So you end up with 17.5. That's what you get right there. Moving on, yeah. Once again, we're not trying to get rid of the 80, we're trying to get what's with the variable. Multiply both sides by 2.5. Multiply both sides by 2.5. And you're going to get, I'm going to put x in the front now, is equal to, positive times a negative is a negative. And just to abbreviate and speed things up a little, sonny, 2.5 times 80 is going to be, I believe it's going to be 200. We get 200. So negative 200 is our answer.